Start streaming. Hey everybody, we're going to try to recover data from an iPhone XR today. This might be the second iPhone XR that I've ever seen. So if you've got an iPhone XR, great choice. These guys are tough. It's been out for a long time, and we don't see a whole heck of a lot of them coming in for data recovery. So this is why I wanted to do a stream since one came in. Let's have a look inside and see if we can start fishing out what are the common failure points, what little failure there really is for the iPhone XR. So this one is coming up to us from data recovery, and we're going to start with the note. So this is from Mary from Georgia, and she wrote out this little typed up note that says the phone was used underwater in a swimming pool with a cracked screen. So that's probably too much to ask for a phone to survive underwater with a cracked screen. So the screen was cracked, used it in a swimming pool. The water got into the phone, fogged up the camera lens. The phone ran for a couple days. Wow, good job, iPhone XR. And then it shut off. So what did Mary do? She attempted to clean it. Sounds fantastic. Great logic there. So she removed the motherboard, the SIM tray, the Taptic engine, and put that in distilled water. That's all pretty reasonable. Great job. And let it dry for 3 days. So assuming it's kind of out on the counter, 3 days probably is fine for it to actually dry out. And then she said, put it back together, the screen will not turn on, but when it's connected, oh no, when it's connected to her computer, it comes up in recovery mode. Boo! So that's not hopeful because, we just did a series, or we're starting our series on iTunes errors, and when something auto boots to recovery mode, that is generally a sign of data corruption rather than a sign of a repairable hardware defect. So we're not sure about this one. But she did not restore it. So she did not click restore because she needs the backup of the phone. Pictures are the most important. And please and thank you. And I think in her original lead, she said that this is a teen daughter phone who swims year-round with a swim team and high school, and she lost 2 years of high school photos and data when the phone was damaged. So also, she said that her daughter's passcode is 20 digits of pi. She loves science and math. That's a really great passcode. I love that. If you have like some long string of data that you personally can remember, then you could just tell everybody, hey, this is what my passcode is. Nobody else is going to be able to remember it other than you. So let's see what we can do for Mary's phone in the swimming pool. So we're going to speed up here. I took the screws out already, and this one has, I think it had a replacement battery. And I took the screws out because I have not opened up enough iPhone XRs to memorize all the screws. A lot of people ask us, how do you keep track of screws? And we use these screw trays that we sell at iPad Rehab Supply. And we use these with a little insert that we make for some of the other phones so that we can kind of standardize how we're going to lay out these screws so that this can get bundled with our storage tray and the screen and everything else, and it all stays together. So we're huge fans of that. So let's just disconnect. Let's see what's going on here. I have not looked at iPhone XR. Maybe I think I did one other back in the summer, but I do not know this phone. So I am flying blind here, and we're going to see if we can figure it out. If it's software error, though, there's not going to be much we can do. So we don't want to spend too much time with any one phone. This looks like a replacement screen. It's got this sort of, new looking stuff. So we'll hope that that's a good screen. It's not cracked, so I don't think it was the one that went swimming. This looks like a new battery. So all of this was fantastic troubleshooting, all very reasonable for what you can do when your phone hits the water. All right, so these are just some flexes and things. I've already taken out the screws to just speed up here. So I'm going to disconnect each one of these a million flexes here, and then we'll take a look at the board. All right, and we can check in with chat while we do that. Hi from Brazil. Why the iPhone 11 Pro Max have 2 IMEI? You tell me. And let's click back over there so we can see. All right. tons and tons of tiny flexes. So the iPhone XR does not have that 10 and 10s split board design, but it also doesn't seem to fail a lot. Maybe that's just because there weren't a ton of them sold. All right, what flex am I missing? This little SIM tray. Got to get peeled up. Or maybe it really is more resistant to water and flexion problems than its predecessors. All right, so here's the logic board. Let's head under the microscope and see if we can see anything. So we're going to do our visual exam now. And let's see. So I can see signs of water. So yeah, this right here on that test point is corrosion that tells us that, yep, this phone was in water. And we're also looking for things like long screw damage or anything that really kind of jumps out at us. Now, we're not going to take off the shields unless we have reason to believe that we need to. So as these phones, more and more modern phones, the shields become more like the Samsung shields in that they become more difficult to desolder. So we take them off if we need to. So we need to know what's under there, and we also need to know whether or not there's a chance that something got damaged under there. So nothing's going to go wrong under the shield unless it has a mechanism. How did it come to be this way? If we see water marks on the outside, then we'll need to take off the shield if we believe there's a problem that we're hunting down and it might be under there. All right, let's look around here, and this really does look fairly well protected from water. As we really look at the foam, there's foam really everywhere. In a lot of these other phones, like the iPhone 6s, where we first started seeing these little foam seals, they would be in most places, but there were always like a spot where a drop of water could roll around. However, the XR, this is the first time I'm looking at it, and really the only place where I see water on the top of the board is right there at that test point. Like a drop of water could roll around here and not really cause any corrosion in any spot that could harm a component, at least so far. So let's flip it upside down, and this side looks like there's a rubber mat. All right, here's some spots that maybe we could have a problem. Let's check it out. Yeah, so this like rubber mat, that's really interesting. Kind of is glued, or some kind of a adhesive is sticking that onto the bottom of the logic board, which itself has a soldered on shield. So you could imagine that water could kind of get here on this end. This to me looks like a bunch of like antenna looking stuff from cross comparing to other devices. I don't know what that chip is. Maybe that could, nope, that's not a BGA. This one here is not BGA, so it's not up above sitting on those little solder balls, so water really can't go underneath it. So as far as waterproofing, this looks pretty good. Oh, and then I'm peeling this all the way off, and now I can see, aha, this is the flash memory chip, and where's the SIM in this one? Where's the SIM? Oh, okay. That's a pretty good design, I think. Back in the housing, here's where the SIM tray is. Normally, the SIM tray itself is soldered to the logic board in all other models, and the SIM tray tends to be a water entry point, no matter what. Water gets in through the SIM tray. So a lot of times, especially on the iPhone X, it's super susceptible to water because water comes in through the SIM tray and then it goes under it to this little city of components on the logic board under the tray. On this one, the SIM tray is part of the housing, so completely replaceable, and it's attached to the board with these little flexes. So that actually seems to be a pretty good design. So typically the SIM tray is sitting on top of this flash memory chip, but not in this one. However, we can see, yeah, there was definitely some water around here. In fact, this is the only spot of damage that we can really see with our first. Come on, camera, stop monkeying around. Stop embarrassing me. Settle down. Stop it. I gotta tighten this up or we're gonna go crazy. All right. Yeah, so there we go. So that guy there is definitely water damaged, and we can see that It's one of the few spots that's not totally protected with either silicone waterproofing or just the foam stickers that seem to be everywhere. And this was under that rubber mat, so it did have some protection. Okay, so we've got our probably sticker shields. I think these look like sticker shields. Let's see what happens if we take a peek under the sticker shield. I'm actually going to change that out for some kind of an X-Acto eraser so that we can see that. Lewis just had a fire. You know, I have to say that if you find yourself setting something on fire more than, once, then maybe, I don't know, maybe it's you, right? If your building goes on fire, you already have a video of a fire, I don't know. Maybe maybe you got too many people in too small of a space. All right, I'm pretty sure also I remember Lewis having to go to a fire safety, like New York City requires you to attend like a class on fire safety. All right, is this actually a sticker shield that's actually covering anything up or not? It is. But it's really tiny, and that's pretty well sealed up, right? So this shield had a pretty tight sticker. I think it'd be really hard for water to penetrate that, and it doesn't look like it really did. Maybe, that's nothing. Okay, and then what about over here? I'm really not sure. Maybe some of you guys know, what is the purpose? Like, why have a sticker here at all? Is it to let out heat? Is it because you need some sort of, this looks like a copper kind of substance in order to do something with RF interference? I don't know. All right, now under here we can see that there is complete coverage by a clear underfill that protects this chip that looks like a power chip, and there's not very much that water could do even if it did get under there, which it did not. Okay, physical exam is over, and our findings are that even though this note says, didn't it say she took pictures? My teenage daughter submerged her phone in a swimming pool. She's on a swim team, and it had a cracked screen. That's as that's as bad as you can get with putting, kind of creating a little bit of water damage. But even still, this phone seems to have stood up to that pretty well. Okay, so now we're going to move on to electrical exam. So we're going to attach our trust-based DC power supply, where you'll have to trust me when I just tell you what it says. So right now what the trust-based DC power supply says is that we have a voltage of battery voltage 3.9 volts that's kind of hanging out here at the end of this battery connector, and I'm going to connect it to the battery. If I can remember which one is the battery, that looks like a battery connector for this kind of battery. I'm going to connect it here, and I'm going to let you know what does DC current do. So it's going to do one of a couple of things. It's going to show us high current consumption right out of the gate, like a short circuit on a main power rail. It's going to show us a high current consumption down the road, which would be a short circuit on some minor power rail. It's going to show us that it's brain dead, which sounds likely because apparently it's in recovery mode, or it's going to show us a boot loop or a relatively normal boot sequence, in which case we might just have an image problem. So let's find out. We are going to attach our DC power supply, and so far I hear nothing, and I can see 0 amps. That's good because it means that we've filled up main power rail with that voltage pressure. It's filled up with blood, and it's holding. There's no leak of current in that system. So next, let's go ahead and prompt it to turn on. Now this is gonna be tough because I don't know how to prompt this phone to turn on. I do not know which one of these is the power flex. Who can tell me in chat which one of these connectors is the power button? Let's see if I can figure out. All right, it looks like from the hand cam, where'd we go? All right, it looks like this is power, and it looks like it's going to be this guy here. So that matches to, let's guess that it matches to the bottom one because it looks tiny and it looks typical. And then we are going to go with the idea that the way power buttons work is they put a small voltage on one of these pins that all we need to do is connect that voltage to ground. Aha, so I got it. And the DC power supply, can you hear it? The fan turned on and it's showing 1.76, 1.8 amps. That's a short circuit. So I'm going to disconnect DC power and do that again, plugging it in right now with the battery connected at the connector, 0 amps, no current. And now we're going to prompt to boot. So one of these was the power pin. Let's see. Let's actually figure out which one it is by process of elimination. Is it U? Nope. So what I'm doing now is I've got one end of my tweezers on ground, and I'm just going to touch these pins. Is it U? 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 Ah, it's that one. And now we know. 1.8 amps of current. All right, so that tells us that we have a short circuit. Where is it? It's probably, from experience, a power line that is an output of the power management chip. But I don't know what the power management chip is, and I don't really know what the possibilities are. So let's look at, I don't think I even have a schematic, but we do have ZXW. So let's pull up ZXW and see if we can guess some candidate lines which may be the cause of a short circuit. So I haven't spent a long time looking at the 10R. In fact, today is the first time. So let's see what we can make of this. All right, this guy, what do we know? This guy's definitely the NAND. That's the flash memory. And then let's see what else looks familiar. This guy looks like a Wi-Fi chip, and it is. All right. I feel like I'm flying blind. I've never looked at this before. All right, what's going on over here? This is a larger chip, and it says BB. That's going to be our baseband CPU, and so then nearby will be a baseband power chip. Let's look for it. I'm just looking at the ways. Here we go. So PMIC K. So this K must be the new phrase, the new label for baseband stuff, or RF function chips. And let's see if we click a few lines if that's true. Yeah, baseband to baseband PMU. So this is our RF section of the device. So this is baseband getting a cell service signal, communicating and sending and receiving RF wireless signals is going to be a dance between the baseband power chip, the baseband CPU, and its similar chips that it works with, which are probably these guys around here, because they tend to be kind of grouped together in one side of the board. All right, then up here we can see this is definitely the main CPU, and so we're still missing somewhere is going to be a main power chip. So let's find it. Let's see, this is a big chip. Is this it? U2700. Let's click on some of these, see what kind of things it does. That sounds reasonable. Yeah, there we go. Power line, PPSoC. That's going to be power for the CPU. PMU to baseband reset. That's a common CPU line. PMU to NFC, which is near field communications. All right, so we can kind of click around in here. Buck 3. That's going to be one of the outputs of the power management chip. And let's see, that's probably going to go to a coil. Probably, unless that's the feedback side. Where is it? There it is. There is a coil. It's going to a coil up here, and on the other side, PP1V8. All right, so this guy, U2700, is our power management chip. It's going to take an input of main, and then it's going to shuffle out all of these various minor power lines that go all over the place. So probably one of these outputs is actually short, but which one? We don't know. We can kind of click around and guess what are these outputs. PPDCS could be him. PP0V8 SoC could be that one. 0V6 could be that one. And there's going to be a ton, maybe 20 to 30 different outputs that any one of those could be the shorted line. So how are we going to figure out which one? We're going to use a couple of strategies. One is my favorite strategy of them all, experience. In other devices, I've seen a current signature pattern that looks just like this. Who knows what it is on other devices? What does it generally mean when you've got a device that has water damage, that has no short on main, nothing wrong with main, but when you prompt it to boot, you see high current consumption. What line is typically short? Let's see if chat happens to know. Let's see. Let's see, is that chat working? I think so. Does chat know what line is typically short circuit when a device has water damage with no short on main? What other line is typically short? Let's see. Charging. Nope. Charging is not usually a factor in water damage, and that's a common misconception, right? So I always tell people to think, how did it come to be this way? This phone is dead because of where the water went, right? So where's it going to be? What do you think? VDD die? Nope. There we go. Joe Ham knows. NAND power. Let's take a look at NAND power. That's right. So NAND power would be my first choice because of that pattern recognition, right? We've seen it before in the iPhone 10. We've seen it in the iPhone 8. We've seen it in the iPhone 7. We've seen it in the iPhone 6 is where it started out, right? So we're going to look at the NAND power lines. Now let's add that to our history. Why do we think NAND power is probably short? Because what happens to a device when you pull NAND power? Does it boot? No. What does it do? If you were to just intentionally short to ground NAND power, what does the device do? It boots to recovery mode. Fake recovery mode, right? It thinks it's in recovery mode because it has no power to the NAND. So it's the same as if you just took the NAND and threw it away or damaged it, right? So it is really consistent with the paper which says it's the device is detected in recovery mode. So that's really helpful. Maybe we have a short somewhere. Maybe it's a short on NAND, and if so, then that's really good news for us. Okay, yeah, Garrison Babbitt. Given recovery mode, I vote NAND. All right, sounds good. So how are we going to investigate that? We need to figure out where's a good place to measure NAND. So in the other devices, and maybe this is still true because this looks like a typical NAND, we're going to find NAND power kind of clustered around NAND. So there we go, right? These big caps that are kind of right on the corner. Let's find these guys and just check to ask, is PP3VO NAND short? So we're just going to take a guess here. And there's lots of different ways to do this. We'll take a guess or two because experience is often a really easy way to solve problems. So here's these two NAND caps, and we are going to use the trust-based multimeter to ask, is NAND, 3VO NAND, is it short in this device like it is in other devices that are in the same situation? So diode mode, really quick on this. We're going to put a red probe on ground and take a reading. So I'm going to kind of push away the silicone so that we can actually get a reading. One side is ground and the other side, aha, is also ground. So ground, ground, short to ground. This means somewhere on PP3VO NAND, we have a short to ground. So that's fantastic, right? Because we can solve a short to ground, and that means maybe this device doesn't actually have a corruption of its flash memory. Maybe it does, but maybe it doesn't. So we're going to try to put out the short, and then we're going to cross our fingers, because if you do have a short on NAND, that's the same as pulling the plug out on a hard drive. If it's writing something down in that moment, that might cause a permanent crash. But maybe not. So that's where we are now. So where is our actual short circuit? Is it the cap that we just dug up? Probably not, because that has no mechanism. How did it come to be this way? Remember, with water damage, the problem is where the water went. Wait a minute. Didn't the water go right up here? Yes, it did. The problem is where the water went. That's where the water went. Now let's ask, is that cap actually on our shorted line? Is it on PP3VO NAND or not? So let's go to ZXW and ask. The guy that looks really bad at the top of the phone, C2650, is that actually our cause of our PP3VO NAND? I bet it is, right? Because things that seem likely are likely, right? Something that's a simple explanation is usually the right one, right? The principle of parsimony. Okay, now just for fun, let's just see, while we're doing a stream, how the iPad Rehab recommended Seek Compact Pro with the iPad Rehab custom macro lens does. And let's see if that actually picks that up just for fun as a source of heat. So let's get rid of the XW and let's check it out on the hand cam. And let's see if we can see a hot spot there or not. We don't know, but we just kind of want to, we're figuring out our signature problems for the iPhone XR. And I just want to know, if you do have a short on 3VO NAND, does it show up with heat? Because it may not. It may show up just, it may show us that just the PMIC itself gets hot. We don't know. All right, so let's try to wake up our thermal cam. Now our thermal cams are just being, I think we have them on pre-order at store.iPadrehab.com, but this is like our favorite tool, and we use them all the time. All right, so we'll try this little color palette. Okay, so in order for the thermal cam to do anything, I'm going to connect this to DC power, and we're going to fire it up and see what heat tells us about where the cause of the short is. We have a pretty good idea from our other strategies, visual exam and experience, but you never know. All right, so I'm going to see if I can power this on, which is really hard to do when it's far away from my hand. Let's move this. Come on, bro. I'm going to have to look under the microscope. I just am too old to have the dexterity that you need. Pretty sure it was this connector. Am I crazy? Didn't we already figure out which one it was to prompt it? There we go. Prompted. All right, now let's see what this thing says. All right, so on this side of the board, it's just reflecting back the sensor. So we're going to flip it over to the other side of the board. And aha! It is definitely showing heat. Let's see, how do I move it so you guys can see that? What I like about this is that you can kind of turn away and it will auto scale. And I can put my temperature reading. Look at that. That's 160 degrees Celsius right there on that spot. So I can kind of move this around to see these other hotspots. Now, why does it look white over here? Right? Why does that look white over there? Oh, it came disconnected. All right, so the answer is probably that you're getting a flashback from the sensor. But this is really, really clear. And I love the crisp detail that you can get, that you can even see whether it's capacitor A or B. A lot easier when you're looking at it instead of it being way out in front of you where you're trying to shine a different camera on it. But there we go. So thermal camera says, yep, that is the hotspot, that same little dude. So now we know that with a 3VO NAND short that we're pretty sure is that capacitor, it will show up on your thermal camera. So next step, let's actually get rid of the problem. So we are going to remove the ugly looking capacitor with my favorite tool, the iPad Rehab X-Acto knife. And why do we use an X-Acto knife? Because it makes it safe. Barbaric, yes, but safe. Because we don't have to use any heat. We don't have to risk overheating the flash memory, which is right there. All right, so now rather than measuring our short there, let's go back to our original spot. If we have cleared the hold of ground in 3VO NAND, then we should not have a path to ground on any of 3VO NAND. And when we measure 3VO NAND, we should get a normal reading, 0.4 in diode mode. So it looks like we've solved that problem. Now here's the real question, and of course, there's no way to know the answer. Did this phone die? Did it get software corruption the moment that drop of water cut power to the flash memory chip? Did that corrupt the chip? Or is it okay? I don't know. So next, we are just going to give it a try. We're going to put some parts on it, and we are going to see if it boots. Jessa, what is the name of this camera? How about somebody go over to store.iPadRehab.com, where our cameras are listed, the ones that we recommend that we sell, with our macro lens. The macro lens is really key to making it work. Who in chat, which one of the mods can go and put a link from store.iPadRehab.com, the Seek thermal cameras that we have for sale. So I believe a box from Seek Thermal showed up here today. So we have a couple of pre-orders on there, but we will be shipping those starting this afternoon as soon as Katrina shows up. Katrina does not mess around. She lets things get sent out the door. In fact, we have the best possible scenario for fast shipping today. Because guess whose phone we fixed last night? Came in special to fix this phone last night for the mailman. Yeah, we fixed John, the mailman's son's iPhone 7 last night. So you just know it. We're going to get speedy shipping today. All right. Let's see. Always good to fix the be friendly to your mail carriers. We love our mail carriers. Okay. Let's see. Should I use Ifixit Essential Toolkit or should I buy the parts separately? Well, it depends on what you're trying to fix. The Ifixit Toolkit is really great when you're starting out. My kids have the Ifixit Toolkit. If you're fixing phones professionally, then you probably, or you might want to think about, the WeHa drivers. Whatever it is that we sell at store.iPadRehab.com is what we actually use. So for drivers, we sell these. These are the WeHa. And then the specialty drivers, if you're opening a 6S, it's nice to have a dedicated driver. And then, of course, the standoff. Once you go standoff, you'll never go back. Nobody goes back to using a lame old flathead after they use a standoff. That's for sure. All right, let me get this microscope out of the way so that I can put the screen on and we can figure out whether or not this phone is going to come back to life, or does it truly have data corruption and it's going to be a sad day for the swim team in Georgia. I don't know. All right, I got to figure out how to attach this screen. How does that even go? Okay, I'm going to start by not doing it upside down. Pro tip: if you're putting a screen on, put it on this way, not the way I was trying to do it, which kind of was like, why don't these connectors make sense? This one's way too small. Okay, because it's upside down. So there you go. I really would like to spend some time and kind of edit this camera setup. I'd like to have a better overhead cam, but there's no space above me. We are in the middle of the room here with no way to attach anything. There's just nothing but ceiling and no walls around to attach a camera. Okay, so we've got the screen attached, I believe. And let's see. There we go. Not the Barlow lens. The Barlow lens, thank you, Paul, for showing us a link, but the Barlow lens is what we use on the microscope. The Barlow lens is what allows you to gain that extra working distance on your microscope. So when we are talking about, actually, I will show you. We're going to take an aside here. Because we've put a lot of effort into our thermal cams. We've tried them all, and we will be releasing a video as soon as I edit it on a cross comparison. We've got the FLIR 1, we've got the various Seeks, we've got the Kienle thermal imager, and we did a big experiment with students that were had never tried any of this stuff. So let's go to store.iPadRehab.com, and in here, let's just search for thermal. There we go. So this is the Seek Compact Pro high-resolution thermal camera, which we sell. They just arrived today, so it's no longer pre-order, with the kind that attached to your phone via micro USB for your Android phones, USB-C for your late model phones, or Lightning for your iPhone. So pick the right one, and that's the camera. So there you go, store.iPadRehab.com, and we'll click this link, and then we'll put it back into chat in theory. There we go. We'll put it into chat. All right, there you go. That's the link to the thermal camera. And then let's go back a step. And then this is the link to our custom macro lens. Now this is the prototype one. Anna developed that. You can see a video. And this is what it looks like in real life, the final product. So let's see. How do I get rid of that? All right, so this is what it looks like, the final product. And this ends up, it's removable, and without the macro lens, you have like way less resolution. So that's the device. This is the macro lens that Anna made. And this is great. So we've tweaked that design a few times, and now super happy with it. You absolutely need that macro lens. That macro lens is what gets you down to the level of an individual filter, an individual capacitor. Totally love it. So stay tuned for our video that shows you that kind of cross comparison of those things. So this is the link then for the macro lens for the Seek thermal camera. So let me post that over in chat. And there we go. All right. Now that we're done with that, we're going to find out the exciting conclusion, whether or not our 3VO NAND short, now that it's cleared, will it boot? So I'm going to plug in this battery because the battery just looks brand new. Maybe it actually has the ability to charge. I don't know. All right, let's see what happens. Let's fire it up and cross our fingers. And then we'll see who can remember 20 digits of pi. All right, show me something. All right, I see an Apple logo, and I can see that the device is consuming normal charging current, so I have high hopes that it's going to boot. Looks like it's not going to boot right now on that battery, so we'll have to switch over to DC power supply. So it's boot looping. Will it boot? I'm going to leave it super still and not mess with it. Keep going, buddy. Boot up. Boot, boot. All the way. You can do it. Will it boot? Let's see. What does chat think? Oh, yay! It booted. Hooray! And we have touch. Now I'm going to see if I can type in 314. It would be really cool if I tried to pretend that I had personally memorized 20 digits. This is really difficult. Even when you're looking at them, man, this is the best passcode there is. All right, did it work? Yes! Haha! So there we go. Let's turn the brightness up. So it is going to be great news for the swim team in Georgia. Let's make it bright. There we go. Display and brightness. Everything's working. Now let's take a quick look to see if this story is true. And we're gonna check out the last picture on the camera roll and see if it's an underwater one or not. Let's find out. Yeah. Wow, that is cool. Look at that. This phone survived this. Isn't that crazy? Here, how do I move it over? This phone survived going underwater. Look at that. Survived. Going underwater. Look at that. Good job, iPhone XR. That was seriously minor damage for a phone with a cracked screen that took a dive underwater. So there you go, iPhone XR. The 2 years of pictures from the swim team are recovered. And this phone actually, I think, doesn't have anything wrong with it. So we're going to reassemble it. And I think it's going to go back out as a working phone. So congratulations to Mary in Georgia. It's coming home to you, and everything is saved. And now we've learned a little bit about the iPhone XR, which is that the iPhone XR is a pretty good phone. So there you go. I will see you guys next time.